This is the first video about how to solve equations. I don't know how many there'll be. But when we're solving equations, we've got one rule to follow. Whatever you do to one side of the equal sign, you do to the other. Whatever you do to the left-hand side, you have to do the same thing to the right. You can do whatever you want, as long as you do the same thing to both sides. Our goal is to get that variable isolated, which means alone on one side of the equal sign. So we'll do some examples. I think that's the best way to show these, is to work through them. So if we have what we call one-step equations, where there's one thing that we have to undo, one thing to fix, a lot of these we tend to, I think, do in our heads, which is a nice thing to do, but also not very helpful for future tougher ones. So let's show our work here. So 3 plus x is 5. You know it's 2. But the way we would show our work for here is we would say, all right, here we have our variable. We want that isolated. What's happening to it? The question we're always asking ourselves here is my variable alone on one side of the equal sign? Here, it's not. Why not? What's happening to it? It's having 3 added to it. So we're going to do the opposite. We're going to subtract 3. 3 minus 3 is 0. X minus nothing is x. And on the right-hand side, I can't just write 5. That's a mistake. I subtracted 3 over here, and the rule to follow is that whatever I do on one side, I must do on the other. So I'll subtract over 3 over here as well. 5 minus 3 is 2. And we can always check by putting a 2 back into here. 3 plus 2 is 5. Yes, that does work. 7 equals x plus 10. This one over here. 7 equals x plus 10 is my variable alone on one side of the equal sign. It is not. What's happening to it? 10 is being added to it. How do I undo that? Well, I can subtract 10. 10 minus 10 is nothing. X minus nothing is x. As long as I remember to also subtract 10 on the left side, so 7 minus 10 is going to be negative 3, then I'll be okay. And if we plug negative 3 back into our original equation to check, 7 is equal to negative 3 plus 10, and negative 3 plus 10, yeah, that's 7. It works out. Always check. It doesn't take long, and you can be sure you don't have to worry anymore. For subtraction, same thing. These are separated into categories: addition, subtraction, multiplication, division. But the idea is always the same. So for subtraction, 3 minus x is negative 5. Is x alone on one side of the equal sign? It's not. So what I would like to do is I would like to get rid of everything that's not x. There are two things. I did two examples like this here. Two things to notice. Number one is that 3 needs to go away. But number 2 is that my x isn't an x, it's a negative x. And if we look on a number line, here's 0, here's counting up to the positives, here's down to the negatives. If I count up by x, or here's 2x or 3x, down here would be negative x, or negative 2x, or negative 3x. How far away is x from negative x? What's 2 whole steps away? So that's really not my answer. I need to make sure that I'm dealing with just the thing I want. So I want my x to be positive. This negative x is not positive. If I make it to be positive, there's one way I can do that. Well, there's a few ways I can do that. One way I can show that. I can add x to both sides. That feels a little bit weird, because why would I be dealing with x? But if we look what happens over here, negative x and x cancels out, that's 0. And now what I'm left with is 3 on the left and negative 5 plus x on the right. No less complex than it was a minute ago, but my x is positive, which is a good sign. Now I look again, is my x alone? No. What's happening? Negative 5 is being added to it. So how do I fix that? Add 5. As long as I do it on both sides, add 5, I'll be good. So negative 5 and positive 5, they equal 0. I've just got x over here, and on the right I have 3 plus 5. I've got got 8. So 8 equals x. And if I check 3 minus 8, is that negative 5? Sure it is. Try another one over here. 17 equals 3 minus q. I have the same problem again. My q is negative. So I'm going to do the same fix that I did last time. So this negative q and positive q, they cancel each other out. Negative anything plus its positive value, that's the additive inverse. I'm left with 3 over there, and over here I have a q and I have a 17. Still not done. Q plus 17 is 3. Q is not alone. 17 is being added to it. So now I've got to subtract 17. Those are gone. Now that's q. And as long as I do the same thing on the other side, I do 3 minus 17 on the other side, and I find that it's negative 14. And I check, is 17 the same as 3 minus negative 14? Minus negative 14 is the same as plus 14. 3 plus 14, yeah, that's 17. We're good. We'll go through the multiplication and division ones, and hopefully we'll still have time to make it through. So for multiplication, 5a is negative 30. I look at my a, my variable. Is it alone on one side of the equal sign? It's not. What's happening to it? It's being multiplied by 5. How do I fix that? I would like to divide it by 5. If I could divide it by 5, I could cancel those out. I wish that were true, so why not do it? As long as I pay the price, as long as I do the thing I need to do, which is the same thing on the other side. So on the left-hand side, I've got a, and on the right-hand side, I have negative 30 over 5. And 30 over 5 is 6, so that's going to be negative 6. And for our original equation, 5 times a, 5 times negative 6, is that negative 30? You can check it out, and yes, that works out. Always check. Takes a load off your mind. Next we have 91 equals 7b. Here's my variable. Is it alone on one side of the equal sign? It is not. What's happening to it? It's being multiplied by 7. I wish I could just cancel out that 7. So I will, as long as I remember to do the same thing on the other side. On the other side, I have 91 over 7, which is 13, and on this side, I just have b. If we check back in the original equation, 91 is 7b. 7 times 13, is that 91? Yes, it is. Let's do these division ones here. So 15 over n equals 3. Is my variable alone on one side of the equal sign? No, it's actually on the bottom of a fraction, which is worth noticing. Variables on the bottom of the fraction are always something that you want to dig out as soon as possible. The way I can do that is similar to what I did up here when I had a negative x and I had to make it a positive x. Here I have a variable on the bottom of my fraction. I want to make it on the top. So I'm going to multiply by n, which doesn't sound great initially because now I've canceled out n, and I want n. But as long as I remember I need to do the same thing on the other side, 3 times n, well, there it pops up. There's my variable again. I'm okay. So now I have 15 is equal to 3n. Is my variable alone? No. What's happening? It's being multiplied by 3. Okay, let's divide it by 3 so that we can cancel it out. That's fine to do as long as I do the same thing on the other side. So 15 over 3 on the left, that's just 5. And on the right, it's n. Can check back into our initial equation. 15 over n is 3. 15 over 5 is 3. Yes, that works. Last one here for now. We've got, what do we got? M over negative 30 is equal to 3. So we've got our variable here. Is it alone? I guess I need a different color because there's blue right above. Is it alone? No. What's happening? It's being divided by negative 30. How do I get rid of that negative 30? Well, if I had a negative 30 on the top, I could cancel out these two. So if I multiply by negative 30, I could cancel that out. As long as I do the same thing on the right-hand side, I should be okay. So now I have m is equal to, that's all that's left here on the left, 3 times negative 30. 3 times negative 30 is negative 90. And I check my initial equation, m over negative 30 is 3. Is negative 90 over negative 30, so negative divided by negative is positive, 90 divided by 3 is 3. Does that work out? Yes, my left-hand side and my right-hand side are equal. I'm going to stop this video here and do one or two more.